Okay, the topic today is solving simple equations. Solving simple equations. So, for example, the equation 3x plus 2 is equal to 5 is an equation because it has a right-hand side and it has a left-hand side and it's connected by an equal sign. Now, when we say solve, it means we want to find a value for x that will make this a truth sentence. We have a hierarchy of terms, and the hierarchy of terms would be that you would have an expression, a term, an expression, then you would have an equation. So an equation is a combination of terms put together by an equal sign. So this is the equal sign right here that makes it an equation. An inequation is one where the left-hand side is not equal to the right-hand side. It is either greater than or equal to, less than or equal to. And that's an inequation, or called an inequality. But to solve one, so let's begin by taking a look at solutions for simple equations. I'll start off with an equation where the variable has 1 as its coefficient. So I'm going to use x, and you'll see it's related to the same idea of number boxes which would have been used in elementary school. So, for example, we would have 1x plus 4 is equal to 6. And so we would be asking the question, what value does x have to be to make this true? That's what we're asking. What value does x have to be to make this true? What value does x have to be to make this true? What value does x have to be to make this true? So that's the question we're asking. Alright, so in this case, what we're going to have to do now is we're going to have to find what we call the additive inverses and the multiplicative inverses. So let me make that vocabulary clear. Additive inverses. Additive inverse. An additive inverse is the opposite in sign of a number. An additive inverse is the opposite in sign of a number, or
is the opposite
in sign of a number or a term. So for example, here is a term, I'll call it term, and I'll put opposite in sign. So that's the additive inverse. If I have 5, the opposite in sign is minus 5. If I have a, the opposite in sign is minus a. If I have minus 3, the opposite in sign is 3, which is plus 3, and so on, positive 3. Okay, so these are called the additive inverses, and the additive inverse is always something that we will have to use to solve an equation. Now, another thing that we have to look at is called the additive identity. Additive identity. The additive identity is 0, always 0. The additive identity is always 0. So, when you add a number and its additive inverse, you get 0. Write that down. When you add a number and its additive inverse, you get 0. Example, 5 plus negative 5 equals 0. A plus negative A equals 0. Negative 3 plus 3 equals 0. So adding a number and its additive inverse gives us gives us 0, the additive identity. So once again, we have to know the additive inverse, the term, the additive inverse. We have to know that the additive inverse is the opposite in sign of a number or a term. So if we have 5, negative 5 is its additive inverse. If we have negative 3, positive 3 is its additive inverse. And the additive identity, you get them when you add a number and its additive inverse. So whenever you add a number and its additive inverse, you get the additive identity. The additive identity is 0, always 0. Okay? So, for example, quiz quick, if I have 2/3, what's the additive identity? What's the additive inverse for 2/3? Negative 2/3. So positive 2/3 plus negative 2/3 gives us 0, the additive identity. Okay? So it holds true for fractions. Okay? Now, what about other symbols like pi? If I have pi, what's the additive inverse? Minus pi. Okay? If I have AB, negative AB, what's the additive inverse? Positive AB, or just AB. By convention, whenever we call a number without saying positive, we know it's positive by convention. So in this case then we would have pi plus negative pi is equal to 0. Now I want you to notice the juxtaposition of the plus and the minus signs. Juxtaposition. And we will look at this in some more detail. But at the moment, just suffice it to say, whenever you have two signs beside each other, they operate on each other. So if you have a minus beside a minus, the result is a plus. If you have a minus beside a plus, the result is a minus. If you have a plus beside a plus, the result is a plus. And if you have a plus beside a minus, the result is a minus. Okay? And these are when they're juxtaposed. We call it juxtaposed. And a term is juxtaposed to another if there is nothing in between. So notice this only operates for multiplication and division. Okay? So we'll learn more about that in the future.
Can you repeat that last incident, please?
Okay. The use of the minus sign. So a minus beside a minus, or minus juxtaposed to a minus sign, is a plus. Minus juxtaposed to a plus is a minus. A plus juxtaposed to a plus is a plus. And a plus juxtaposed to a minus is a minus. Notice that the term juxtaposed means beside each other with nothing in between. So when you're doing, for example, A minus B, then it's simply A plus minus B, but we just say A minus B, okay? Because the A plus minus B, the minus and the plus are juxtaposed, and then we go beside each other. Plus and a minus, which is here, becomes a minus, which is here. So we can simplify the juxtapositioning of signs, and there are only two, plus and minus. Okay, now we're going to look at the mechanics of solving a simple equation. So let's look at the equation x minus 4 is equal to 6. X minus 4 is equal to 6. The first thing that we need to do is isolate the variable. Step 1. Step 1, isolate the variable called x. Isolate the variable. In this case, it's called x. Okay, so to isolate the variable x means to get rid of any non-x term on the side where the x occurs. In this case, there is a negative 4 along with the x, so we have to get rid of the negative 4. To get rid of the negative 4, we're going to use the additive inverse of negative 4. What is the additive inverse of negative 4?
4.
Positive 4. So what we're going to do then is we're going to go x minus 4 x minus 4, now the opposite is plus 4 is equal to, and since we had put 4 on one side, the next step is to, step 2 now, balance the two sides. Step 2, balance the two sides. So that will give us x minus 4 plus 4 is equal to 6 plus 4. Note that we have balanced by putting the plus 4 on both sides of the equation. At this point now we can go ahead and we will find that the additive inverse and its number have given us 0. So we end up with x plus 0 because minus 4 and plus 4 gave us the additive identity, which is 0. And so now the answer is 6 plus 4 is 10. Now, the fact that we got x plus 0 is equal to 10, when we add 0 to anything, what do we get? The same thing. So that means we are going to get x is equal to 10. And we have solved our first equation. And we have done a simple equation solution by using the additive inverse and additive identity method. Solving equations. What is a solution? A solution is a value we can put in place of a variable, such as x, that makes the equation true. For example, x minus 2 is equal to 4. When we put 6 in place of x, we get 6 minus 2 is equal to 4, which is true. So x is equals 6 is a solution. How about other values for x? If we use 5, we would get a different number, 5 minus 2, which is not equal to 4, so it's not a solution. If we use 9, it would not be a solution. In this case, the only solution is x is equal to 6. Sometimes there can be more than one solution. We'll look at those at later stages. Okay? So, I don't like this one. Cut. Example, x plus 5 is equal to 9. Talk me through this one. What do we do first? Step 1,
Get rid of what is that?
get rid of anything that is non-x. So we want to get rid of the 5 on this side. So what do we do? So how do we do that? X plus 5 minus 5 is equal to 9 minus 5. And what happens to the plus 5 and the minus 5?
Cancel each other out.
Okay, because they are
Inverse.
what type of inverses? Additive inverses. So we get x plus 0 is equal to 9 take 5 is 4. And when we add 0 to anything, we end up with what we had before. So x plus 0 is still x. So x is equal to 4. Okay? Alright, so do these. Do these quickly. Okay, so for x plus 3 equals 7, the first thing that we need to do is x plus 3 is equal to 7. We want to isolate the x, so it's x plus 3 minus 3 equals 7, and to balance, minus 3. The plus 3 and the minus 3 are additive inverses, so they give the additive identity of 0, so it's x plus 0 is equal to 7 take away 3 is 4. And adding the additive identity to anything, you get back what you had before. So we end up with x is equal to 4. Number 2, or which would rather me do? Number 2, number 5, does it matter? It doesn't matter. So number 2, so the number 2 is x minus 3 is equal to 9. So since we have minus 3, the additive inverse of minus 3 is plus 3. So it's x minus 3 plus 3. And whatever we did on the one side, we have to do on the other side. So we have to add. And so the additive inverses give the additive identity. X plus 0 is equal to 12. And anything added to 0 is whatever it was before. So x is equal to 12. And that's it for this class today, folks. So this will be up